Hello, here we are again, finishing the last question. Question 7, interesting question. Have a look at this question. Do you see how interesting these molecules are? Do you see the difference between codeine and the heroin? It's pretty. It looks pretty similar, aren't they? They look pretty similar. So what are the differences? Do you see here? The only difference is codeine has got these groups and the heroin has got these two groups. So if you know how to replace this group, the hydroxyl group, and whatever this is a ether group with these are two ester groups, man, codeine to heroin, codeine to heroin. By the way, do you know when these crooks get busted? uh, I mean, talking about the drug cooks, they normally find lots of painkillers because it has got codeine. I don't know what they're doing with the codeine. Maybe they, yeah, you know what I mean. Anyhow, let's look at the question. All right. Let's look at the question. We don't want heroin. We don't want codeine. Adrenaline is so good sometimes. Okay. Name and circle the functional group found in both adrenaline and codeine. Okay, let's look at that. Adrenaline, codeine. This is hydroxyl. Okay. This is ether, 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 ether linkage. Not glycosidic. There's no sugar. This is not nothing to do with sugar. So you should say this is ether linkage. You got a amide secondary amine. This is a tertiary amine. This is a tertiary amine as well. That is in codeine. The question is asking name and circle the functional group found in both adrenaline and codeine, but not heroin. Adrenaline has got hydroxyl, hydroxyl, hydroxyl. This is got amine as well. Okay, here it is a secondary amine. Okay, heroin has got, oh, there are tertiary amine here, glycosidic here, not glycosidic, it's wrong, 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 wrong. It is ether, 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 ether. This is ether, and this is ester. All right, now let's look at the question. Name and circle the functional group found in both adrenaline and codeine, but not in heroin. What is that? Not in heroin. So this could be found in both adrenaline and codeine. It should not be found in heroin. Oh, that's simple. That is the hydroxyl functional group. Hydroxyl functional group, right? Hydroxyl, isn't it? Yeah, that's simple. That's hydroxyl. Name the circle the functional group found in heroin, but not in either adrenaline or codeine. Oh, that's simple as well. That's the ester functional group. This is ester. You see that? This is the ester functional group. Make sure don't circle the methyl. Don't circle the methyl part. Then you won't get marks, which is the ester. Okay, make sure you don't circle the carbon of the methyl, right? Easy. All right. A reaction sequence for synthesis of 2-propanamine. Oh, I don't like the way they named it. I like to say propan 2-amine. Propan 2-amine, not 2-propanamine, which should be okay, but propan 2-amine. Yeah. All right. So what are we doing here? Okay, if you are going to make amine, you are starting with alkane, man. You know, alkanes, boring molecule. What do you need to do with the alkane? You need to get it excited. Get it excited? How do you get an alkane excited? Huh? That's the only way you can get an alkane excited. Do you remember the only way? What is the only way? Add halogens. Kick one of the hydrogen of the alkane with a chlorine or bromine, then you can get the alkane excited. When you get the alkane excited, you never know what it is capable of. Huh? All right, let's see what we can do here. All right, so we got alkane. You want to make 2-chloropropane or 2 chloropropane. In order to do that, they're making it easy. Ultraviolet light, okay, 2 chloropropane. Then how do you do that? Okay, 2 chloropropane here. So, okay, that's 2 chloropropane. All right, now you have to remember that if you are going to get amine, NH2 part, okay, you need, it's something to do with ammonia. I've said that to you all the time. And you also know that alkanes and the chloroalkanes undergo only substitution reaction. So there will be a substitution reaction that will make what? That will get the chlorine kicked out by NH2, like so, and you got CH3, right? CH3. So 2 chloroamine. Okay, state the reagent and condition needed to complete that I've already said that ultraviolet light and chlorine gas. You have to mention ultraviolet light, otherwise this reaction will not simply happen. Okay, make sure you mention ultraviolet light and chlorine or bromine substitution. Okay, that's simple, isn't it? I've done everything, man. I've done everything. Finally, we finish this sack. I'm hoping to do another sack today, so that at least give you a what? It's all about me doing sack to help you, and most importantly, to get you kick started, give you the boost. Otherwise, it doesn't really matter how many sacks I do. What it really matters is how many sacks you do. You do, okay? You do, not me. You. So let's start doing it at the beginning together. All right. See you soon. Bye.